Hi, my name is Madison Matthews, and this is my Physics 2 lab report on charge tape revisited. So it's a continuation of the lab from last week. So the purpose of this lab is to compare the electric forces of the floating U-tapes using a point charge model, which we did last week, and then this week we're using a line of charges model. And what we did to do the line of charges model was we divided the U-tape into many different segments. You'll see in the code it was 50, and then we treated each segment as a point charge and modeled that with GlowScript. So we used GlowScript to code, and then the stuff we used last week to do the actual physical model were tape, ruler, tabletop, and then the stools like we went over last time. So the results from last week were that the charge on each tape was 1.167 e to the negative 8, and then the line of charges, the charge on each tape ended up being 2.37 e to the negative 8. So fundamental physics concepts we used for this, same as last week, Newton's second law, which describes the relationship between momentum and net force applied to a system, as you can see down there. And then we also use gravitational forces, which describe the attractive force between two objects. And we also used Coulomb's law, which describes the force between two electric charges, as seen below. So a quick recap of our Lab 1 findings. Again, like I said, the charge on one piece of tape was 1.167 e to the negative 8th, and you can see our system and our surroundings in the diagram on the left. And then I also added again the mass of tape, length, width, and area of tape because we used that in our code from this week as well. So some calculations that we did, same as last week, are this is the force of gravity, and then the force of gravity is going to be equal to the electric force because those are the only two forces acting on the system. And then from there we can calculate for Q and solve for what Q is using this equation below, where R is the distance between the tapes and then L is the length of the tape. And you can see this modeled over on the left with, again, tape B and then the electric force going up and the gravitational force going down. So our GlowScript model for this week, over on the left, you can see the constants up above. So we have mass, net charge on one tape, tape length, distance, all of that. And then below, we included the function for the electric field, which is the equation we looked at before. And then on the right, this is different than last week. We used line of charge to calculate instead of the point charge like we did last time. And then that chunk of code below there is creating the top tape and the bottom tape for the stuff on the next page. So here we have the calculations for electric force on the top tape due to the bottom tape. And then below that, we have calculations for the net electric force and gravitational force. And if we go to the next page, you can see what our code spat out at the end. So we have the magnitude of the electric force, and a little explanation of what this picture is again, the arrow going up is the electric force, and then the arrow going down is the gravitational force, and then we have tape 1, which is that little red sliver, and tape 2, which is the blue one below it, and then the electric field is the little green spiky things. Some assumptions and possible sources of error in this lab, very similar to last week. Some assumptions we had to make are that we had to ignore air resistance and friction, assuming that they are negligible in this situation. And we also had to assume that each piece of U-tape we made had the same amount of uniformly distributed charge. And then some possible sources of error were just handling the U-tape for too long and messing up the charges, like with our hands or with the table, the stools, anything like that. And then also just human error from measurements because it was hard to measure the floating tape. And then discussion questions. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So like I said earlier, from the point charge model, we got 1.167 e to the negative 8th. And then the line charge model this week, we got 2.370 e to the negative 8th. And then below, why do these estimates differ and which is closer to the real value? And that is because the line charge model offers a more precise calculation than the point charge model, because what we did in the line charge model is took the tape and split it into 50 different segments in our code. So it's closer to the real value because it uses those smaller segments across the tape instead of generalizing the charge in a singular spot. So instead of treating the whole tape like a point charge, we had like 50 little point charges going all across the tape, which made our calculations more accurate. So thank you.